It's a popular inventory counting solution that allows businesses to count a limited number of different items on a regular basis without having to count the entire inventory. Its goal is to adjust inventories without hindering operations and improve inventory accuracy regularly rather than waiting for large-scale counts that can be run quarterly or yearly. Cycle counting allows you to count fast-moving items more frequently than slow-moving items, for example. This can be done by making materials that are to be included in cycle counting, by marking materials that are to be included in cycle counting with the cycle counting indicators. Examples of such indicators in QED are ABC class and cycle count interval that you can define in Item Master. There are three main types or methods of cycle counting. Control group cycle counting is when counting is focused on a small group of items that are counted many times in a short period. This repeated count process will show any errors in the count technique which can be then corrected. It's usually used when a company starts using cycle counting. Random sample cycle counting is when number of items to be counted is chosen at random. The count can be performed each day or so that a large percentage of the items in the warehouse is counted in a reasonable period. ABC analysis cycle counting is an alternative to random sample counting. This method uses the Pareto principle, also known as 80-20 rule, as the basis for this technique. The Pareto principle states that for many events, roughly 80% of the effects come from 20% of the causes. The ABC cycle counting method uses this principle to assume that 20% of the parts in a warehouse relate to 80% of the sales. These are the A items as defined by ABC class. The principle is then extended to two other categories where B items account for 30% of the items and 50% of sales, and C items represent 50% of the items in the warehouse, but only 5% of sales. If you're using cycle counts in QED, you most likely follow one of those methods, although your definition of ABC class items might be slightly different. There are many benefits in using cycle counting. Errors revealed during cycle counts allow to promptly identify the cause and implement corrective procedures. Frequent cycle count results in high levels of inventory accuracy, and as a result, increased confidence in inventory and more accurate inventory valuation. By running regular cycle counts, you can potentially eliminate the need of physical inventory counts. No need to halt operations or pay employees overtime for inventory counts. And elimination of physical inventory counts will lead to shorter period closing processes and better resources and time management. Having regular and properly documented cycle counts affects external audit scales. If auditors feel they can rely on the cycle count results performed by the company on a regular basis, they may scale down the number of auditing procedures performed. That will result in lower charges to the company. With all said, the benefits of regularly running cycle counts are obvious, but without proper tools, you might not get all of them. If you have and use a dedicated barcode application to enter count results into QED, the process of entering counted quantities into QED is solved. But what if you do not have one? And even with having one, how do you handle cycle count worksheets efficiently? And what is your solution to having all cycle counts properly documented? I want to show you a data loader designed to resolve most of the issues you might have with cycle count and provide all necessary tools to properly document the process. Cycle Count Data Loader is a fast and efficient tool to generate count sheets and input cycle count results. It allows you to use list of items to count or a worksheet for recording count results, record the quantities counted and adjust quantities on hand, generate a count log to keep track and document your cycle count routine, and at any point of time, generate a report with cycle count results details. This worksheet is a turnaround document. Once printed and given to warehouse personnel, they will use it to record counted quantities and then return it to the person who is authorized to enter results into QAD. The cycle count worksheet can be generated in a number of ways. You can use one of the cycle counting methods I mentioned earlier by specifying different selection criteria in the header. For example, you can pick for count 10 items with 40% of them being from class A, 30% from class B, 20% from class C, and we will leave the remaining 10 for the rest of the items. You can also choose to pick them randomly, and you'll probably want to exclude items you have counted last week. So we'll put last count to date, let's put it as April 9. Once selection criteria are entered, and click on download after logging into QAD. I will get the list of items to be counted. Downloaded data have a detailed information about each item, such as current system quantity on hand, product line, standard cost, and total inventory cost, and more. If you don't want this information to appear on the cycle count worksheet, you can hide the columns before you will print the worksheet. So like this. Then you can choose what you want to go to the worksheet. And then you can go and print. You can give printed count worksheet to warehouse personnel that will be performing cycle counts. Once you received the count results back, you can enter them in Excel spreadsheet and click on Upload. Let me unhide my system quantity. I will use it to enter the results. You will see right away differences between system and counted quantities, and optionally can enter remarks if discrepancy is above the certain percentage. Let me just enter some count results. So this will match the original, and this will be for example, right now, template is preset to ask for remarks if count variance exceeds 5% for items from class A, and then 10% for items from class B, and 20% for items from class C. So, for example, if I would count here, C1000 will work, yeah. So the variance is more than 10%, so I'll need to put some remark. I will try to upload, and on upload, cycle count data loader will first validate entered data, and then we'll try to enter count results as an initial count into QAD. If counted difference is within predefined tolerance amounts, QAD will accept submitted quantities and update inventory balances. Count tolerance amount and percentage for item with different ABC classes you can define in inventory control menu in QAD. But if there is an error, you'll get one. If initial count is rejected due to tolerance limit, you need to determine if another physical count for the item needs to be taken, or you can override the tolerance restriction by entering quantities counted as a recount. QED will change the inventory balance to be equal to the numbers counted. If cycle count results uploaded successfully, data loader will automatically generate cycle count log report with details of all items being counted. There will be information about date and time of the count, total GL impact, and references to GL transactions for each item involved. You can save or print this log file for future references. So you can just print it, put any signatures on it, and file it. If you will need at any point of time to look at past cycle count results, you can do so from the Report tab. For example, if I need to check if there were any cycle counts since April 1st, I can enter last count from as April 1st in the selection criteria and then click on download. I will get details of all cycle count transactions if there were any. Here we'll see information about item, its location, initial quantity counted and difference, quantity counted and difference between them, GL amount, accounts, sub-accounts, and cost centers involved, affected by the count. This is the kind of information finance department will really appreciate. And as you can see, entering cycle count data loader has a number, cycle counts with data loader has a number of advantages over using just only barcode scanners. Main one is you can see what will happen in QED in terms of transaction being generated and total cost impact. And also with the loader, you minimize the number of count errors by being able to compare counted quantities with the system quantity prior to recording inventory discrepancy into QED. By running cycle counts more frequently, you can greatly improve inventory data accuracy. And this easy to use Excel tool that I just showed and its real-time access to QED inventory data will help you to increase productivity and reduce errors.